Hey guys, Chris here again from R&D Off-Road. And today, as promised in my last video on battery systems, today I will be letting the proverbial cat out of the bag. So let's start at the beginning. Well, not quite at the beginning, but in the last video we had a look at the pros and cons of how an alternator works in a split charging system. And I explained to you that a deep cycle battery was almost impossible to charge up to 100% state of charge with an alternator, especially a modern day one. The problem with a modern day alternator is that they're linked to the ECU of the motor vehicle, most of them. So they're designed to charge up the crank battery relatively quickly and then downscale their power in order to improve fuel efficiency as well as reduce emissions. And in doing so, this means that while the second battery is connected and still desperate for power, it's not getting enough because the alternator is completely slowed down. The other problem is we need to get the battery up to 100% state of charge, and to do this a deep cycle battery requires a 3-stage charging cycle to get it from 50-60% depending on what it's been drawn back up to 100%. So before we take a look at our putty cat, let's have a quick look at the 3-stage charging cycle. Stage 1 is the bulk charge cycle. And during this cycle, the battery will accept the highest voltage and amperage possible without overheating. Bearing in mind that if the battery does overheat, it'll cause higher resistance and reduce the amount of charge the battery will accept. AGM deep cycle batteries during this bulk charging cycle will accept between 14.6 and 14.8 volts until they get up to around about 80% state of charge. This is when the bulk charging cycle is completed. Next up is the absorption charge. During this cycle, the battery wants, similar to nice high voltage as before, but with a decreasing amount of amperage, ensuring that the battery doesn't overheat. And this cycle, although slower than the first cycle, even though we're now at 80% already, takes the battery from 80% to 95%, which is where we kick in for the final stage, which is the float charge. At the float charge, the voltage decreases as well as the amperage, and it now slowly brings the battery up from 95% to 100% state of charge, and then keeps it there, which is where we get the term trickling charge from, or trickle charge from. And those are the 3 most important phases that one needs to keep a deep cycle battery up to 100% fully charged. Ta-da! So we've worked out an alternator is simply not the right tool to charge a deep cycle battery. And what is the right tool? Well guys, it's time to let the cat out of the bag. Welcome to the world of DC to DC chargers. And my favorite one at the moment on the market is the Orion TR Smart Isolated DC to DC charger. I'm going to open the box up and show you really good manual inside, which is obviously essential, and the charger itself. Like with all Victron products, when you pick up the item you can feel it's very heavy, it's solid, it's got heating fins on the back, on the front, input and output wiring which are very straightforward, and it's just a good solid piece of kit which already tells me it's good quality. Now I've tested these in the bush extensively, so I know they work, but when you open something like this and it feels great, you just know you're in for a good buy. So the most important thing to now understand about this unit is it works the same as a 220 volt smart charger, but it operates, as you can see here, 12 volt to 12 volt, which means it takes power from the alternator and then performs the 3-cycle charging system we need to charge a deep cycle battery. And it'll do all of this at 30 amps, which is fantastic. So we've got the charger. The other important thing is, as we know with the auxiliary battery systems, is we need an isolator. And this acts as the isolator as well. So the way it works is when you start the motor vehicle and the car starts running, this unit will pick up the voltage from the alternator and start charging the auxiliary battery. The minute you switch off the car, the unit will then switch off as well, and it'll isolate your auxiliary system from your main system, which is obviously an essential part. So we can charge, we can isolate, and then for me, probably the third most special part of this, or trick part of this little unit, is the fact it's the same as the BMW 712 we looked at a little while ago. It also has Bluetooth connectivity, which means when you're driving, you're able to monitor the device to ensure that it's working all the time. And you can do all of that through Victron Connect. Just like the BMW monitor, using Victron Connect gives you a massive amount of functionality on this program as well. So you connect to it using the app, and once you're in there, you can set things like there are 8 programmable or pre-programmable algorithms for different charging cycles on batteries. So depending on what type of battery you're running in the car, you can set the charger to charge at different voltages to whatever that particular battery needs to charge it properly. Next up, you can set things as well like the input voltage. So the switch on or switch off voltage required to activate the system when the car is started. So it gives you a really big chunk of information through, once again, the Victron Connect app, which I think is what sets this apart from most of the competitors in the field. And finally, just another important factor on this unit, because we have experienced this in the past on other units, is it's got a lot of built-in electronic protection. So it'll protect against overloading, voltage derating, overheating, and even short-circuiting during fitment, etc. So it's well protected, which means obviously safety for the unit. So we've now had a look at it. It's a fantastic piece of kit. I know it works, which is great. And I think we should just have a quick look at how it operates out in the field and show you a little bit more on the Victron app. So we promised you a field test during lockdown, which means we're in a field. That's sort of the best we could do right now, but it does feel kind of outdoorish. So before we go on to having a look at the Victron app, I'm just going to run through the hardware and just show you a little bit of what's wired up in our vehicle. We have seen it before in a little glimpse in the first test of the battery monitor, but let's have a quick look at the product in the Hilux. So over here we've got the Orion TR Smart Charger, 12 to 12 volt, 30 amp unit. We've got input wires coming from the alternator and a set of output wires going straight down here, and those run directly to a Victron lithium battery. Yes, we are spoilt. It's a great piece of kit, the battery as well. But today, as mentioned, we're talking about this unit. The top left, we've got a blue flashing light, and the blue flashing light is indicating that we're connected via Bluetooth. And we've got a green light in the bottom right-hand corner, which we'll notice will come on once we power up the unit, which, as I've said earlier, will power up the minute we start the vehicle. Guys, it's back to Victron app time. So we select the app, which we've seen before. And before we switch on the Orion Smart Charger, let's just go and see what our battery's doing at the moment. We click onto the BMW, and we'll see the battery is at 91% state of charge. The voltage is 13.33. The fridge is running, so we're currently using 0.39 amps. It's a bit chilly out here. And our main battery is at 12.44. So we'll go back and we'll connect to the Orion. And we'll see here, immediately it'll measure and tell us that the main battery is at 12.5 volts. The unit itself is off because the vehicle isn't running. And we'll just click up there on settings and take a peep at that first. And here's some of the functionality I mentioned earlier, the input voltage lockout. The different battery algorithms can be set in here, the float charge, bulk charge, absorption, etc. So you can fiddle around in there. Let's go all the way back. And now I'm going to run off and start the car, and let's see this baby in action. So we'll take a little stroll around the field. Okay, the car has started, as you can hear, and it's going to take a few minutes. The voltage has gone up on the main battery, and bang, the unit is in action. Immediately you can see we're on bulk charge. The car voltage is at 12, and as mentioned earlier, it's going to pump up the voltage based on what the battery needs. We can see that going right up, and if we click on the graph button, we can actually see that it's going to start with a bulk charge, go into absorption, and then finally going to a float charge. We'll go back to status, and we can see there the alternator's tapped off a little bit,
And yet, even while the alternator's tapped off, the DC to DC charger is still keeping the voltage right up at 14.1.
So guys, as you can see, the alternator was putting out about 12 volts at the time, and the DC to DC charger was upping that voltage to 14 plus volts. That is doing it at 30 amps as well. So we ran a test trial while we were in Botswana. We were running the same system over Christmas. The temperatures were very hot, and we worked it out that between the end of the late afternoon game drive and waking up the following morning, we were using approximately 36 amp hours. That was the fridge running, lights in the evening, as well as a 12-volt fan in the tent. Yes, it was reasonably warm, but we'd also been able to manage the system by getting the data from it. Realized that the next morning on our first game drive, we were able to replace that 36 amp hours of used power within about 42 to 46 minutes every morning, taking the stress away from having to worry about battery consumption all the time. Big plus indeed. So between a great unit putting out super voltage and super amperage, we also had the luxury of the Victron Connect app. Guys, I hope you've enjoyed this video. Short clip with Chris, not so short apparently. And till next time, thanks very much indeed for watching.